pretty sure that's in 8th grade. And heard about systems before and you've done them. You just may have forgotten. Today we're going to be graphing lines. Do you remember graphing lines in Algebra 1? Hopefully you should have. Yep. So a system of equation. When I talk about a system, that is when you have two or more lines or equations. And really what we're doing is looking for where those lines cross. Most of the time, if you have two equations, the majority of the time, they have a common point or an intersecting point. Not always, but most of the time they do cross once. Those points where they cross are called the solutions. So if I'm talking about a solution, or I say, what's the solution? I'm asking for the point where they cross. So let's say we have two intersecting lines. I'm just going to draw that right here. Two intersecting lines. How many times do they cross? Once, right there. So intersecting lines have one solution. What do parallel lines look like? Yeah, or this way or that way. Yep. So those are parallel lines. What do you know about the slopes of parallel lines? They have the same slope. So in Algebra 1, you learned about perpendicular slopes are the same. How many times do they cross? That's the point of them being parallel. So parallel lines have no solution. Now sometimes you may even get two equations, and when you graph them, same line. So you graph one of them, and you graph the other one, you graph the other one, and they completely overlap with each other. If that happens, we say that it has infinite solutions. Sometimes you may not realize that the equations are identical when you first see them. We'll see an example of that today. So graphing lines, when we have a system of equations, you're usually just going to graph them when I say graph them. I will give you a graph, a picture of a graph. Graphing is not always the best method. We'll see the way the equations are set up. Sometimes graphing is not that easy. But the ones I'm going to give you today are. So we're going to graph two lines and try to find the point where they cross. It's easiest to do when they are in slope-intercept form, which is this y equals mx plus b. And if you remember, the m, so the number that's with the x, is the slope. And slope is rise over run. So the number on top, your rise goes up or down, depending on if it's positive or negative. Run goes right for positive, left for negative. And then the y-intercept is your b. B is your y-intercept. So when you are graphing a line that's already in slope-intercept form, where do you start when you're graphing it? What point do you put first?
The y-intercept.
You start with the y-intercept. Good. So if we go down here to number 1, what is my y-intercept? Positive 2. Right. So I'm going to put a point on the y-axis at positive 2. And then my slope is 4/3. So a positive 4 means I count up 4. The positive 3 means I count right 3. What happens on this graph when I try to count up 4? I run off. Alright, so if that happens, you can switch your directions. You can switch both of them. So instead of going up right, you go down left. And it ends up being the same. So down 4, left 3. When you're graphing these lines, you need to put as many points that will fit on your graph. Sometimes that's only 2. Sometimes it's 3 or 4. Put as many as you can. And then you're not just to go all the way across the graph. Now my second line, what is the y-intercept? Gavin? The second line on number 1. Negative 1. Good. And what is my slope? Kristen? 1/3. So I'm going to count up 1, right 3. Or I could switch. Instead of going up right, I could go down left. So down 1, left 3. Did my 2 lines cross? Yep. What point did they cross at, Janae? Do what? What point do they cross at? What is this point right here? What coordinate is that? Your x value. You're just giving me a coordinate like an xy. -3, and then the y is -2. Very good. So my solution is the point -3, -2. Number 2. My first line on number 2 has a y-intercept of what, Addison? 4. And it has a slope of what, Aiden? 1/3. So I'm going to count up 1, right 3, or I could go down and left. Anymore. I'll run off of my graph. Equals -2x minus 3. What is my y-intercept? And Ethan, what is my slope? Good. So if you have a number that's not a fraction, you can put a 1 underneath of that. And so this tells me that I'm going to count down to, the 1 is positive, so down and right. Down to right 1. Or I could go opposite and go up and left. Did those two lines cross? Yes, they did. And what is that point where they cross, Danica? Yes. -3, 3. I want you to try number 3. So your point where they intersect is -3, -3. Now number 4, the line y equals 1. Does anybody know what that looks like? Yes, it is. So a line that's y equals 1 means that every point on that line has a y value of 1, which really just means it's a horizontal line that crosses through the y-axis at 1. So like every point, no matter what the x is, has a y value of 1. If it said x equals 1, it would be a vertical line that crossed through the x-axis at 1. And then we have the line y equals -2x minus 1. So we have a y-intercept of -1 and a slope of -2 over 1. So down to right 1, or I can go up and left. So what is my solution, Madison Hayes? -1, 1. Good. Number 5. This line is not in slope-intercept form. So there's 2 ways that you could go about graphing this one. Okay. The first way, so we have 3x plus 6y equals -12. Sometimes this works and gives you nice whole numbers, sometimes it doesn't work. But this first method is usually a little bit easier. Okay. You use this one by finding the intercepts. So in Algebra 1, you learned how to find the x and y intercepts. Right. To find an x-intercept, you plug 0 in for y, and to find a y-intercept, you plug 0 in for x. So if I want to plug a 0 in for y, essentially what happens, 6 times 0 is just what? 0. So I can literally just cover that up and pretend it's not there. If 3x equals negative 12, what does x equal? Negative 4. So I have an x-intercept at negative 4. So I could go back to my graph, go to the x-axis, and put a point on negative 4. For the y-intercept, I basically cover up the x, and I have 6y equals negative 12. What would y equal? Negative 2. So I can put a point on the y-axis at negative 2. That is one way to graph these. The other way is by putting it into slope-intercept form, is actually converting it. So if we have 3x plus 6y equals negative 12, what I could do is try to get the y by itself. So we need to move the 3x over. So you'll subtract 3x from both sides. And we get 6y equals negative 3x plus 12. And then we divide everything by 6. To get y equals, what's negative 3 over 6? Negative 1/2 x. What's 12 divided by 6? 2. So my other option was to do this. Sometimes you end up having to convert it into slope-intercept form. Sometimes that's not the only option you have. Especially like if I would have found an intercept is like, 12. If I would have got x equals 12, I couldn't graph that. So I couldn't do it that way. I'd have to do this. Some people just prefer doing it this way anyway. So I would have a y-intercept of 2. Wait a minute. What did I do wrong here? Oh. See, I put a plus there. So that should be a negative 2. See what I did? So that I should have had a negative 3x minus 12, not negative 3x plus 12. But because regardless of what I did, my y-intercept should have matched, and it didn't. So my y-intercept is negative 2, which I'd already got. And then my slope was negative 1/2. Okay. And that did fit in with my line. So it's kind of up to you which method if you're not given one in slope-intercept form, it's kind of up to you to decide what method you prefer. Okay. My other line is in slope-intercept form. What is my y-intercept? Negative 5. What is my slope? Negative 1/2. Negative 1/2. If you see a negative in the front, that negative either goes in the top or in the bottom. It doesn't go with both. It's not down and left. Okay? A negative goes either in the top or in the bottom. So I can go down 1, right 2, which really doesn't fit on my graph, or I can go up 1, left 2. What's happening with these two lines? They're parallel, which tells us what? No solution. Could I have figured that out without putting it on the graph? How? Whenever I got that one into slope-intercept form, I saw that my slope was -1/2. This one has a slope of -1/2. Same slope, parallel lines, no solution. And then last one we're going to do, number 6. So these lines are not in slope-intercept form. Neither one of them are. I've got, let's see, negative y equals negative x. They're almost in slope-intercept form. Almost got the y by itself. What is in front of the y?
1.
A negative or a -1. So how could I easily get rid of that -1? Divide everything by -1. And that's going to be a y, a positive x, and a plus 6. So I'm going to say this one is y equals x plus 6. So what is my y-intercept? 6, and unfortunately you're just going to have to guess where that point would be. What's my slope? 1 over 1, which tells me I go up 1, right 1. I can't do that. So you can flip and go down and left. Down 1, left, down and left. Okay. Very good. Now my other line is 3x plus 18 equals 3y. Is my y by itself? No, it's almost by itself. There's really only one little thing over there, so how could I get rid of the 3? Divide everything by 3. And that gives me x plus 6 equals y. Notice anything? It's the exact same line, which tells me what? Infinite solutions.